This video is a remake of an earlier YouTube video that shows my method of making sturdy road cases for vintage brass instruments, with the technique being applicable to cases for many other things as well. I hope to streamline the script to show things without unnecessary delays and pauses. In addition, some of my techniques have evolved somewhat since the previous video was made. In this instance, a road case will be made for a Civil War vintage brass instrument, specifically an upright E-flat bass sax horn, which has a pitch similar to that of a modern 3-valve E-flat tuba. The case is constructed to have a semi-monocoque structure, where loads are shared by the thin skin and lightweight frame. The frame is made from pine boards. I buy so-called select pine boards in a 2-inch by 2-inch cross-section from the local Home Depot store. I use my table saw to rip them to 1 1/4 by 1 1/4 inch cross-section. A smaller case might use a 1-inch by 1-inch frame member. Here the ripped boards have been cut to the lengths required by the frame dimensions. Vertical frame members will have mortises, and here you can see cut marks showing mortise dimensions. The mortise will be 3/8 inches wide and 1 1/4 inch deep. Here I use a 3/8 inch bit in my router table to cut the mortises. Here the mortises have been cut. The horizontal frame members will have tenons, 3/8 inch wide by 3/8 inch deep. I use my bandsaw to cut the tenons. Here all horizontal frame members have tenons. Here the frame members are test fit with horizontal section tenons fitting into the vertical section mortises. Here the instrument is propped inside the frame to verify good fit. Frame adjustment can still be made if the case is either too large or too small. For this instrument, there were maximum width and height limitations per shelving that the case will go on for storage, which required me to position the instrument at a tilted angle inside the case. The frame sections were glued together using Gorilla Glue. Glue is applied to the tenons, and the mortises are moistened with water, then assembled and held tightly together using band clamps. Right angles in all 3 axes are verified before the glue starts to set. Gorilla Glue foams before hardening, and some will ooze out of the joints. After the glue has set, a chisel is used to remove excess foamed glue. The case sides are made from 1/8 inch thick masonite, a steam-cooked and pressure-molded hardboard product. I buy them pre-cut to 4 foot by 4 foot pieces at the local Home Depot store. The 1/8 inch thickness is readily available and inexpensive, and is strong enough for even fairly large cases without weighing very much. The masonite panels will be inlaid into the frame. I typically use a fixed base router with a 1/2 inch bit and equipped with a fence to allow consistent cutting of the inlay. The router shown is a fancy model, but an inexpensive model would work just as well. Here the router fence is adjusted to get the edge of the bit lined up with the planned edge of the inlay. The bit needs to be wide enough to remove all wood in the inlay area. Here is a small section of inlay routed. I did not have the frame held down firmly to the floor by my foot when I was doing the routing, so the flame shifted and the router departed from the inlay area in a couple of spots. This can be fixed later. Here a scrap piece of 1/8 inch masonite is test fit into the routed inlay area, so to verify correct depth of cut. The idea is to make the inlay slightly deeper than the thickness of the masonite, so the frame can later be sanded down to match the level of the masonite. Here the end of the frame has been routed to form the inlay areas. Here I do another inlay depth test before starting to route the other end and the 4 sides of the frame. The other end of the frame has been routed here. For routing the 4 sides of the frame, I clamp the frame to my table saw. This helps to reduce the chance of the frame shifting during routing, which can cause mistakes. Here all 4 sides of the case have been routed. Fitting the masonite panels into the inlaid areas of the frame is a simple and straightforward process. A critical first step is to mark each of the 6 frame sides with identifying numbers or letters. Here I have marked one side as A. Masonite makes very fine dust when sawed, so I always use a paper mask over mouth and nose. And because I'm using the table saw, I wear a protective face shield. I use the table saw to cut the masonite panels, and the resulting fine dust is evident. I use a shop vacuum frequently during this process. The 6 panels are initially cut out to be about 2 inches greater in each dimension than the actual inlaid panel dimensions. I start by cutting off one corner of an inlay panel, which is necessary due to the rounded corners of the inlay areas, and a result of the routing process. I fit the trimmed corner of the panel into one corner of the first inlay area, pressing the long side firmly against the long edge of the inlay area, which is the left side in this photo. The panel is marked to match the frame marking. This prevents mixing up the panels and makes sure that I don't lose track of their orientation relative to the frame. I pull the panel back from the long edge and mark where the short edge of the inlay, on the left in this photo, crosses the panel. I push the panel ahead and mark the other crossing of the left inlay edge and draw a line between the two marks. I use the table saw to cut the panel along this line, and now 3 sides of the panel will fit the inlay. Note that I have to trim the corners as I go along. Using the same technique, I mark and cut the 4th side of the panel, and now the panel fits well into the inlay area of its frame side. By this technique, the fit of the inlay should be about as good as shown in this photo. The panels of the other 3 sides are fit using the same technique. The 2 end panels are likewise fitted. It is necessary to have a good collection of beam clamps. I buy the cheap ones that are carried by most hardware stores. I find that the big box stores such as Home Depot only sell the expensive name brand versions, perhaps $30 to $40 each. I buy the ones that my local Ace hardware store stocks, which run perhaps $7 each. They are adequate for the task of gluing the inlay panels into the frame. I orient the frame with side A facing up and panel A at hand. I paint the frame inlay area with water and likewise paint the inside edge of the masonite panel with water. I lay a generous bead of Gorilla Glue into the frame inlay area. I quickly flip the case upside down and perform the same water and glue process on the opposite side, and then turn the case on its side and use beam clamps to press the 2 opposing side panels into their inlay areas. It is imperative that the pads of the clamps can reach and press only on the masonite panels and not on the frame, and that the pressure is only applied where the frame can back up the pressure, so that the masonite panels are not bowed inwards. Pressure must be applied every 8 inches or so to prevent the masonite flexing out of the inlay. After a 12-hour period to allow complete curing of the glue, the same process is used to the other 2 side panels. It is normal for some glue to foam out of the inlays on both the exterior and interior seams. If foam does not come out of the seams, this indicates that not enough glue was used. The idea is that the glue should at least foam to fill the seams where the edges of the panels meet the edges of the frame inlay areas. In preparation for gluing the end panels, I put some sort of a riser on the floor. This is to provide a platform on which to rest the bottom panel without the frame itself resting on the floor, and to prevent any seeping foam from gluing the frame to the floor. If long enough beam clamps are available, they can be used just as with the other sides, but for this particular case I did not have the correct beam clamps, and therefore it was difficult to adequately press the end panels into the inlay areas. So, even though the idea is to make the basic case box using only glue, in this instance I make an exception and have some brad nails on hand if needed to hold the end panels in place during gluing. Both end panels have been glued, and one end rests on the riser on the floor, while a heavy weight rests on the top end. Some brad nails were used where needed, when weight alone did not press the panels evenly into the inlay areas. After the glue has completely set, a chisel is used to remove excess foamed glue from the panel seams. Not shown in the photos, at this time I used a belt sander to carefully sand down the pine frame to match the level of the inlaid masonite panels. There will inevitably be some gaps in the seams and at the corners, and also some routing mistakes that need to be filled before proceeding. I have found that this particular epoxy wood filler product works well for this purpose. This is a two-part product, and once the hardener is mixed with the resin, it begins to set up quickly. So I only make small batches, enough to do one side of the frame at a time. Application is done with a putty knife. Here all gaps have been filled on one side of the case. Here all 6 sides have been treated with the filler. I use the same belt sander that I used previously to sand smooth the filled areas. I use an orbital sander fitted with fine sandpaper to give a finish smoothing to all sides of the case. I buy all my case hardware from a company called Reliable Hardware in the Los Angeles area. This includes pre-cut aluminum valance strips, spring-folded handles for the case top and ends, corner protectors, hinges, and latches. The latches are part number RH-A2056. They feature spring-retracted latch arms and spring tensioning with butterfly knobs that fold flat into recesses. The latches hook into so-called keepers, which will be mounted to the top part of the case, or the lid. These are part number RH-0373. The hinges are self-stopping type that prevent the case lid from opening more than 90 degrees. These are part number RH-1827. I use between 2 and 4 hinges per case, depending on size. The handles have grips that fold flat into recesses, and they have a spring action to hold them in the retracted position except when deliberately pulled out. These are available in steel and aluminum versions, and to minimize weight, I use the more expensive aluminum ones. They are part number RH-0512AL. I usually put one handle on each end of the case to help pull the case from storage shelving, and then a third handle on top of the case for carrying purposes. Smaller cases may have only a single carrying handle. The case needs corner reinforcements, and I use 2 compatible versions. The RH-1570 parts are for corners that will not be used as case feet, while the RH-1560 parts are similar but also have form feet on them for use on the bottom corners of the case. The long sides of the larger cases need a valance to keep the edges aligned, otherwise the masonite is not stiff enough by itself. Reliable Hardware sells part number RH-1170, which is a 12-foot length. They will pre-cut it before shipment, which significantly lowers shipping costs. The pre-cuts are free as long as the cuts result in 3 4-foot lengths. Custom cuts can be done, but at extra cost. I use spray lacquer paint for my cases instead of the more common enamel spray paints commonly carried by hardware stores. I find that its characteristics are better, and it is much more tolerant of the time periods between application of multiple coats. I use the Krylon brand's industrial lacquer that they call Acrylic. It is readily available through industrial suppliers, including MSC Industrial Supply that I use. I put on several coats of gray primer, followed by 3 layers of color coat. The case in this video is for an organization that has all of their cases colored a distinctive shade called True Blue in the commercial market and OSHA Safety Blue in the industrial market. I use white paint for stenciling numbering that identifies the case and the instrument within. Here are the Krylon numbers for the gray primer, the blue, and the white. I have to do my painting in my basement, and I usually do my case making during the winter months when opening the door to fresh air would be a problem. There are two main issues with this: the mess and health hazard of the overspray and the health hazard of the solvent vapors. To minimize overspray, I use a pair of cheap 20-inch box fans, which I think cost about $9 each at the hardware store, with the cheapest pleated paper furnace filters taped on. Run on high speed, they draw most of the overspray particulates into the filters. The rest of that settles on the floor and can be vacuumed or mopped up later. For the solvent issue, as well as the overspray particulates, I always wear a half-face respirator such as the one shown. It has two-stage filters, with the first filter blocking the particulates and the second stage of the filter being an activated carbon type or something similar that intercepts the vapors. To prevent the overspray from settling on the lenses of my glasses, I wear goggles that surround the glasses. I always leave the room after applying a coat of paint. Here is the case after its first coat of gray primer. Notice how the fan filters have drawn much of the overspray into them. Here the second coat of gray primer has been applied. The orbital sander is used to smooth the primed surface at this time. Now I use a circular saw to cut the case in half, or not in half strictly, but to form the bottom case as well as the lid. The saw's fence keeps the cut line correctly positioned and true. After the case is cut in two parts, the inside is finally exposed for the first time since the masonite panels were inlaid. This is a good time to chisel out any remaining glue foam. On the edges where the case was cut, the thin masonite is rather fragile and needs reinforcement. I could just put the valance on here, but I don't like the way it looks overlapping the masonite. It's certainly uneven at the corners if done that way. So instead I put thin wood strips cut from the original select pine boards and glue those along all of the exposed masonite edges. I typically use 3/8 inch thick wood strips for these larger cases. Here regular wood glue is used. The valance strips can then be attached to these thin wood strips because they are thick enough to take the screws that will hold the valances on. Although not strictly necessary, I like to add fillets of wood to provide extra support for the ends of these thin wood strips so they can better transfer stresses to the frame. These are bonded to the case using epoxy. On larger cases, there is a lot of stress placed on the case when the top is hinged open. To provide a way to transfer stress from the hinges to the frame, wooden rails are added in all positions where there will be hinges mounted. For the end of the rail that joins the frame, I use a tenon on the rail and I cut a mortise into the frame using a small router or milling bit in a Dremel rotary tool. For the end of the rail that joins the thinner wood strip along the case opening, I use a simple rabbet in the rail that mates with the strip. I use epoxy or wood glue to secure the rails to the frame, and the glue is also liberally used to bond the rails to the back side of the masonite. Small beam clamps hold the rails in place during gluing. Thinking ahead to when I will attach the corner reinforcements to the case, I realize that one of the 3 screws on each corner reinforcement will go into masonite, which by itself cannot hold a screw. So I place 1/4 inch thick wood fillets at frame intersections where these screws will be. They are epoxied in place. Just as with the hinge rails, the masonite panels are not strong enough to anchor the latches, so I use 1/4 inch craft plywood obtained from the local hardware store to form reinforcement plates that span between frame and the wood strip at the edge of the case opening. I use regular wood glue for these. Clamps and blocks secure the top ends, while angled sticks that are wedged in place keep pressure on the bottom ends. Since this is a larger case, the masonite panels can act like the head of a big bass drum. To dampen this down, I add a stiffening rail in between the two latch reinforcing panels. It is formed and attached just like the hinge rails. It is time to make the panel cutouts for handles and latch hardware. The two handles on the case ends are centrally located, and here I use a Dremel microcircular saw attachment to make the cutout on the masonite, followed by test fitting a handle. For the third handle, which will be the carrying handle, it is important on larger cases to position that handle such that the case balances well when being carried. Here I place the instrument in the case bottom, positioned as it will finally be, and rest the case on a piece of scrap copper pipe. Sometimes I use a scrap of electrical conduit or a large diameter wooden dowel rod for the same purpose. By rolling the pipe with my fingers back and forth, I can cause the case to balance either left or right of the pipe, and I can finally locate the case's center of longitudinal gravity. The carrying handle assembly will need to be positioned in line with this point, instead of centrally positioned longitudinally. For this handle, it is important to take into account how the handle in the carrying position is located differently from when it is retracted. I position the overall handle assembly off to one side of the case center, so when being carried the case will hang straight. With this adjustment combined with the aforementioned center of longitudinal gravity adjustment, the carrying handle will provide the most stable and comfortable carrying position. This photo shows my finger pointing to the point where the carrying handle will be when in use, while the position of the handle assembly is offset. Here, a cutout for one of the two latches has been cut. The wood here is too thick to use with the Dremel micro saw, so an electric saber saw was used instead. The latch is test fit and the holes marked for the screws. I use sheet metal screws instead of wood screws for these cases, and I drill pilot holes before putting in the screws. Just as with the hinges and latches, the handles require reinforcing rails. The two rails for the end handles are cut into the frame with rabbet joints. Regular wood glue is used, and a heavy weight presses the joints together as the glue sets. Two more similar rails are used for the top carrying handle, and here a scrap piece of weighted plywood spans the rails as the glue sets. As with the stiffener for the front panel of the case, two stiffeners are added for the bottom of the case. They are made from 1/4 inch craft plywood, and regular wood glue is used. The two stiffeners have been positioned where I expect to mount the two main foam pillow blocks that will support the instrument in a later step. Here all the woodwork on the case is complete. From this view, it is apparent that most of the case surface is still only the 1/8 inch masonite, which allows the case to be much lighter weight than it would be using plywood throughout. With woodworking done, a final coat of gray primer is applied. Remember that the first two primer layers were given a light sanding when the second coat was complete. Finally, it is time to apply the color coats of paint. As before, a drop cloth made from craft paper is used, and the two filter fans are put to use. 3 coats of color are applied, with a pass of the orbital sander between the second and third coats. The first hardware to be mounted to the case is the aluminum valance. The valance comes with the male and female halves joined, since they are extruded that way. Bending them back and forth on the extruded dividing line will separate them. The female valance is here clamped into place on the bottom of the case, up against the wooden edge stiffener, with the edge of the valance aligned with the edge of the case. The valance is designed to be fit over the edge of a case made from 1/4 inch thick plywood. Since it is not being used that way on this case, I use sheet metal screws passing through drilled holes in the valance into the wooden edge stiffener. 2 of the female valance strips are used, one on each of the long sides of the case. Similarly, the male valance is mounted to the wooden edge stiffener on the top lid of the case. The pointed part overhangs the edge of the case so that it will dock with the female valance on the case bottom. 2 of the male valance strips are used, 1 on each of the long sides of the case. Next, the hinges are mounted to the case. To make sure that the case closes fully, beam clamps are used here to press the top and bottom halves of the case together firmly. The case is marked for the 4 hinge positions, which must line up with the reinforcing rails inside the case. Each half of each hinge has 2 mounting holes. The holes close to the hinge pivot are located such that their screws will hit the aluminum valance. So instead of the sheet metal screws used elsewhere on the case, for these particular holes, machine screws are used instead. At the positions of these holes, small pilot holes are drilled all the way through the masonite, then the wooden edge strip, and then through the aluminum valance, and then drilled larger with the appropriate size tap drill. This is followed by tapping the valance to match the threads on the machine screws. Sheet metal screws are used for the outer holes on the hinges, since those will go into the wooden reinforcing rails. These hinges are self-stopping types, which means that they have integral wire bails that fold flat when the case is closed, but which form a stop when the case lid is open 90 degrees. The weight of the lid holds the top in this stable position. Next, the handles on the case ends are mounted. Pilot holes are drilled, and then sheet metal screws are used to mount the handles. Note that holes are not drilled in places where there is no support rail behind the masonite. The top carrying handle is mounted the same way. Here, the case is open to make a final test of the hardware mounted up to this point. The latches are of a type known as valance spanning, which means that one end is raised to have clearance over a valance used on the nearby case edge. Since on this case the valance is mounted inboard, 2 small metal washers are used to form spacers at the 2 holes under the raised portion of the latch. Here, both latches have been mounted using sheet metal screws into the reinforcing wood behind the masonite. As with the hinges, it is important to make sure that the case is closed tightly when fitting the latch keepers, so beam clamps are again used. The latch keepers are mounted to the lid of the case using sheet metal screws into the wood behind the masonite. The screws here are not long enough to extend all the way to the aluminum valance. An important trick here is to first make sure that the latch is fully in the closed position, then align the keepers under the latch hooks, pulling the keepers tightly against the hooks, and then mark the holes for the screws. But when actually drilling the pilot holes, offset the drill from the points marked about 1/16 inch further away from the edge of the lid. This will assure that when the latch is closed, it will pull extra tightly on the keepers. The other thing to remember is to select sheet metal screws that are large enough to have virtually no clearance when passing through the holes in the keepers. The reinforcing metal corners have rounded edges and corner, so here I use a milling bit in a Dremel tool to chamfer the case corner edges. Here the corners have been mounted using sheet metal screws. Several views of the completed case shell are shown. For blocking the case to fit and support the instrument, I used closed-cell, chemically cross-linked polyethylene foam. It is soft and non-abrasive and chemically inert, will not mar or scratch the instrument or react with any part of it, and will not absorb oil, sweat, or water or anything else. It is firm and yet has a surface softness. If compressed, it will return to its original shape. It can be machined using saws, mills, and routers, Dremel tools, and drills. The downside is that it must be purchased in large sheets from industrial foam suppliers, and it is relatively expensive. Because I build a lot of cases, I stock this foam in 2-inch and 3-inch thicknesses. Here I am starting to form one of the 2 side pads for the rim of the instrument's bell. The foam has been sawn to clear the frame, edge reinforcement strip, and valance. The foam is cut to fit snugly and to contact wood in as many places as possible and on multiple sides. This is important because no adhesive is very effective in holding polyethylene foam by itself, and only the combination of tight mechanical fit and adhesive works well. It is also important to always use sawn or machined foam edges where adhesive will be used, because the opened foam cells where cutting has taken place will provide a better anchor for the adhesive. Here the bell rim is supported by foam on two sides and bottom, and the instrument is temporarily held in the desired position by scraps of foam. Here's the foam block that will fit on the end of the case to support the flat of the bell rim. It has been sawn to clear the two handle support rails and milled with a Dremel tool to clear the handle assembly itself. There are many good surfaces here for the adhesive to work with. Some of my cut lines are visible in this photo. Due to the darker gray color of the foam, I use a Sharpie marker having a fine point and metallic silver color for good contrast. Here is a view of the Dremel router attachment that helps maintain an even depth when doing routing operations on the foam. A Dremel milling bit is used, the same one used to make mortises on the wooden support rails of the case. Here are all the pieces of foam blocking for the bell. They are all still supported only by their tight fit with the case, and can be removed for further tweaking if necessary during the remainder of fitting of the instrument's blocking. Here is how the bell fits its blocking. On this case, the rim extends above the blocking since there is plenty of clearance inside the lid of the case. Next, the blocking to support the bottom bow of the instrument is arranged. A piece of 1/4 inch thick craft plywood has been attached using epoxy to the frame and two handle support rails at the end of the case opposite the bell end. Here, a piece of 2-inch foam has been cut to support the instrument's bottom bow. It only needs to press against the instrument such that the bell will not slip out of its blocking. Again, the instrument is test fit before making additional blocking. As before, it is held in the desired position using scraps of foam. The case blocking is designed to allow the instrument to be lifted straight up and out, but to disallow any other motion inside the case. Next is the pillow block that will support the upper main part of the instrument. It is intended to rest on the stiffening plywood below and against the front and rear masonite panels. It has been notched to clear the frame in two places and also to clear the edge reinforcing wooden strips near the top. It must fit firmly in position without adhesive, so it takes some work to wiggle it into position. Once the pillow block fits the case well, it is removed and its shape is transferred to a piece of corrugated cardboard, which is here shown being test fit in the case. Next, the instrument is placed back in the desired position in the case, and at the intended position of this pillow block, a number of measurements are made from the front, rear, and bottom of the case and to the places where the pillow block will contact the instrument. A large caliper is used to measure instrument diameter at the critical places. A pattern is drawn on the cardboard to match the measurements. A compass and ruler are the required tools for this. An X-Acto knife is used to cut out the cardboard pattern. Then the cardboard is put back into the case. Once again, the instrument is returned to its desired position, and the fit to the cardboard is tested at all points of contact, and any discrepancies are noted and measured. The cardboard pattern is then transferred to the foam block. Again, I use a silver metallic fine point Sharpie marker for this. The foam is then cut to the pattern and returned to fit in the case. I find that a bandsaw is best used for cutting the foam, but other kinds of saw can also be used. The instrument is again returned to the case to verify fit, but this time the new pillow block is left in place to help support the instrument, while a similar process is then used to make the second pillow block. The second pillow block is formed by the same process as the first pillow block, starting with fitting the outside of the block, then taking measurements, and laying out a pattern on corrugated cardboard. Testing the cardboard pattern in the case, transferring the pattern to the foam block, and finally returning the pillow block to the case for fit verification with the instrument. The final blocking involves making 2 smaller pillow blocks for the case lid. These are usually simple rectangles that are sized to just lightly touch the top of the instrument where it rises above the 2 lower pillow blocks. It is a good method to initially cut these top blocks a little bit too deep, then do a test fit and see if the case will actually close, and when it will not, then remove the blocks and trim slightly, repeating this until the case almost closes, but a slight pressure is required to close the final fraction of an inch. On this case, the case closes to about 3/16 of an inch, and then slight pressure is required to finish closing the lid, which compresses the top foam block slightly. With all blocking cut and fitted, it is time to remove the blocks, apply adhesive, and then return them finally to the case. Liquid Nails heavy-duty construction adhesive seems to be about the best choice for this application. This only works well if the foam pieces fit snugly against the wooden case structure. For best results, the adhesive must be applied to every foam-to-wood contact point. All of my instrument cases include a small storage box intended to hold mouthpieces, valve oil, and slide lubricants. I'm naturally suspicious of latches in this situation because they need to be fairly small, and most readily available small latches are not very secure and can come open due to shock and/or vibration. A heavy metal mouthpiece will do a lot of damage to a brass instrument if it is allowed to leave the storage box during transit and bang around inside. So I designed my in-case storage boxes such that it is physically impossible for the box to come open when the instrument is also in the case. I usually arrange for the storage box to be located on the bottom of the case with a padded lid that the instrument touches when it is in the case. For this particular case, this meant having the storage box taller on one side and then sloping down to a shallower dimension near the bottom edge of the instrument. I usually make the storage box out of scrap pine strips or scrap 1/4-inch craft plywood, and epoxy is used to hold the pieces together and to the case. I use small brass hinges from the hardware store to mount the lid to the storage box. Here I have used the Dremel tool with a milling bit to cut 2 recesses in the double-thick rear panel of the box and used the small screws that come with the hinges to secure them to the wood. To assure that the sides of the box are well attached to the case structure, I look for ways of increasing the surface area to be epoxied. The rear panel is already double thick to allow mounting of the hinges. For the left side and front, I added small strips of scrap wood. The right side gets some support by being up against the second foam pillow block, and indeed I used some Liquid Nails adhesive between the wood and the foam in this location. Note that I decided to raise the hinges slightly for better fit of the lid, so I added some shims made from cardboard taken from the back of a pad of paper. Here is a view of the completed storage box, showing how its lid extends under where the instrument will pass over. I also add a small wooden knob from the hardware store to help open the box, although it is not really necessary since the user can just reach under the front edge of the lid to lift it up. The knob is positioned such that there is ample clearance between it and the space occupied by the instrument. I always make sure that if the storage box is left in the open position, no part of it or its lid will impact the instrument if a careless player puts it in the case this way. Not shown is a step that I usually take to prevent damage to the case if any oils or lubricants leak. I usually apply a couple coats of polyurethane varnish to the inside surfaces of the storage box. The last step in the storage box fabrication is adding a pad of suitable size and thickness where the instrument will contact the box lid to hold it closed. Most of the cases I make are destined for an organization that has a meaningful serial number system for identifying instruments and their cases. The most significant digit defines the size of instrument, with a 1 being an E-flat cornet and with increasing numbers down to a 6 being an E-flat bass. The second digit indicates the shape of the instrument, such as bell up, bell forward, over the shoulder, helical, etc. So from the serial number shown in this photo, it is already easily apparent that the case holds a bell up E-flat bass instrument. The letter suffix simply differentiates different examples of instruments having serial numbers starting with 6-3. I use a set of brass stencils for adding the serial number to the case, along with some masking made from pieces of craft paper. The serial numbers are made using white spray lacquer described previously in this video. The numbers are painted on all sides of the case except for the bottom side. Here are a few photos of the finished case with the instrument inside. Costs for such a case for a large tuba-sized instrument are as follows: $109 for all wood, masonite, screws, wood filler, adhesives, and the expendable filters for the box fans. $67 for several cans of gray primer paint and finish color paint. I didn't include the white paint since I used so little of it. $85 for case hardware, including valances, hinges, latches, handles, and corners. $30 for the foam. This comes to about $290 material costs, labor not included. I hope you found this video to be interesting.